Welcome. This point of the lesson, we're going to focus on conduction, convection, radiation, electromagnetic radiation spectrum, and whatever other tangents I happen to go on as we're going through. Okay, so our first page here is talking about what makes up the biosphere. So bio has to do with living, sphere is a layer of the earth, okay, around. Hydrosphere is the water, so we're talking about oceans, lakes, rivers, glaciers, the water in the atmosphere as well, the water vapor like clouds, hail, okay? And then while we can spend a minute or two learning about the troposphere and stratosphere, those are the upper layers of the atmosphere. That's a bit less of a focus, okay? And then main source of energy is the sun. It's always the sun. Okay, and then the plants use photosynthesis to get our food chains going. It causes evaporation to get our water cycle going. For the carbon cycle, it even gets that going with the photosynthesis from the trees. Yeah, so the sun is our main source of energy. Insulation has to do, this isn't the insulation one like this word, insulation. That's like warm mitts or oven mitts so that you don't freeze and you don't get hot. So insolation has to do with sun. Okay, so insolation versus insolation. Like the word sol, I'm pretty sure in Spanish is probably sun, I think. Okay, so insolation has to do with how much sun is in a particular area. Okay, what are some components that affect the sun? Well, if it's sunny or not, like clouds, or daytime or nighttime, but also the tilt of the Earth's axis, okay, which you learned about in space, but we can relearn it a bit, okay. Then we have net energy budget surplus. That means when you have too much energy, okay, and net energy budget deficit. That means we're having less energy, okay. Deficit means not enough, surplus means too much. Okay, so when you look at energy transfer, okay, you learn two words, conduction and convection. And usually I find people understand what those things are, but they get them mixed up. Okay, so let's try to remember. Conduction is where you have to be physically touching the other particles to transfer the energy. Okay, now this goes for electricity. Right? This goes for heat. Those are the two ones we care about the most. So we're talking solids here. So usually your examples is a metal spoon that we put in a hot pot. I don't know why people would ever use a hot metal spoon, but they do. Okay, or we are definitely not sticking any metal devices in light sockets because they are good conductors of electricity and heat. So this is also relevant when we do the chemistry unit because the metals, which are on the left-hand side of the periodic table, they tend to be our heat conductors, right? Things like iron, I don't know, the other ones. Okay, and the insulators are things like air, right? Wood tends to be a good insulator from heat, unless it lights on fire, which is combustion. Okay, so conduction is where you are transferring heat or electricity by direct contact of the particles. So that's what this picture is showing here. It's showing the little red dots that are touching the little red dots and they're vibrating faster as they heat up. Okay, and so if you had a piece of metal right here, like a paper clip, okay, this end would heat up first and eventually this end would heat up. Right? It's a lovely picture of convection here. We have a heat source at the bottom, so let's pretend this is a water bottle, glass one hopefully, and we have a heat source like a stove or a lamp or a candle, okay, and it's showing how hot air or hot water rises because it becomes less dense. As the particles move faster, they move farther apart, and then as they cool off, the particles move slower, and they get closer together. They become more dense and they sink. Okay, that's how come quite often in a room, the vents will be on the bottom, right? It doesn't make a lot of sense for hot air from a furnace to be pumped in through the ceiling because a lot of that hot air is just going to stay on the ceiling anyway. So if you have it on the bottom, the hot air rises and creates a convection current. You might have noticed this before if you ever open a window, and there'll be a draft, okay, and the cold air tends to go more down, and that's what it says right here in the words. Okay, so something with more energy has a lower density. Particles move faster, they spread farther apart, they expand, they rise. Then as they lose energy, they become more close together, the particles move slower, and they sink. So this is just in fluids, and you're like, what's a fluid? A fluid is a liquid or a gas. So water, oil, shampoo, oxygen, nitrogen. Okay, so there's convection for you. Radiation comes in about 7 or 8 forms, and it's called the electromagnetic radiation spectrum. I'll just turn this off, it's a bit distracting. Okay, so radiation comes from the sun, and quite often when we think radiation, we think like Spider-Man, right? Gets bit by a radioactive spider. So yes, there is that kind of radiation too, but heat. Here, I'll show you a picture, hang on. Okay, these are our forms of electromagnetic radiation. Okay, so let's zoom in and take a quick recap on those. What's a good picture? Let's go with this one. Okay, so when we have different types of radiation, they're just on a spectrum. We don't actually have something that's specifically microwave radiation or X-ray radiation. It has to do with the wavelength of the energy waves and their frequency. So what I'm talking about is these wiggly lines down here. So I usually use a slinky in class to demonstrate. The types of radiation with less energy have a longer wavelength. So the distance between the two crests, or the two troughs, the bottom parts, or the troughs, this is crest, trough, crest, trough, crest. Okay, that is called a wavelength. And so these ones are really, really long, really far apart. Okay, and gamma rays, the higher radiation ones, cosmic rays, they have a lot more energy. The frequency is a lot higher. Frequency is how many times they happen in a cycle. And their wavelength is a lot shorter. Okay, so low energy, long wavelength, low frequency. High energy has short wavelength and a high frequency. Okay, so quite often when you're younger, you're asked to put these in order. Okay, so you have radio waves. I should find one with words on it. Radio waves, microwaves, so that powers things like TVs and whatever this is, Wi-Fi. Okay, cell phones. And then we have infrared. Okay, infrared has the word red. That helps you remember what side it goes on. Okay, so this is heat, this is thermal energy, and then visible light is what we can actually see. There are some species, though, that can see a little bit into the infrared, like snakes. They can see infrared a little bit. And there are some species that can see a little bit into the ultraviolet radiation spectrum, like bees. So the way to remember the colors is it's red, orange, yellow, green, blue, indigo is usually the one people don't know. Indigo is this color. And then violet. So Roy-G-Biv, R-O-Y-G-B-I-V, Roy-G-Biv. So if you ever see Roy-G-Biv, that's what they're talking about. Okay, and this particular picture shows the exact wavelengths of light, but we don't have to memorize those. Next we have, this is a tanning bed, so we shouldn't use them because they can give you skin cancer, but ultraviolet radiation, which is blocked by the ozone layer, unless we wreck it, gives you suntan, gives you skin cancers, okay, causes damage to other species too, like coral. Coral don't like ultraviolet radiation. X-rays are pretty cool, okay, you can see bones with them, but once we start getting to this zone, this is where you start getting cancer, right? Because it has enough energy to wreck your DNA in your cells. Okay, so there's some types of energy sources that give out all these kinds of radiation, like the sun. is able to emit all these kinds of radio waves, thermal energy, X-ray, ultraviolet, right? So that's why our astronauts actually get more radiation than we do, because they're not blocked by our atmosphere. Okay, so there's some information for you about radiation. If you're keen on learning some songs, because that helps you study about heat transfer, radiation, and conduction, you're welcome to take a look at this amazing video. Here, I'll just show you some clips. Okay, heat transfer, excellent songs. Alright, so if you like to learn through songs, that is just on our grade 7 science page. So there's grade 7, and you go here to heat and temperature, and it's on the topic 6 page. So I'll let you open that up in your own time. Okay, there's a couple videos here about insulation, but they're kind of baby videos. Okay, here's another one. It's a song about the electromagnetic spectrum.
Electromagnetic spectrum. And there be sure to stuff them all are the gamma rays. All together it's the EM spectrum. Electromagnetic spectrum.
Alright, so again, if that's your style, you are welcome to use that to learn. I have a couple Google Translate words in Tagalog here if that helps you learn, but not a whole lot. Okay, so we don't have time in this class to watch a whole Bill Nye, but it's quite good. And I mean, who doesn't like Bill Nye? And if you don't have a lot of things to do this summer, you're welcome to go ahead and click this link and watch that video. Okay, I would like to do this with you, but again, we don't have time. All right, so that's it for that section that I want to show you. Next up here is just taking 2 seconds to focus on convection currents. So when we learn these, we do definitely talk about them in terms of the atmosphere and how that affects the weather and the climate. But where you would have also learned this before is when you're talking about convection currents in the mantle. So this is the cause of earthquakes, seafloor spreading, and the reason that the Horn of Africa is eventually going to split off from Africa, and there's going to be a new ocean, like a little sea in the middle. We're getting as farther away from Europe, North America, as fast as your fingernails grow. So that's about how fast they're moving. We're getting closer to Japan and Asia, and eventually Alaska is going to crash into Russia, right? So the reason those tectonic plates are moving is because they're being dragged by the thick kind of molasses layer of molten rock inside the Earth's crust. Okay, so these convection currents in the Earth's mantle, they rise too because the core is quite hot and the surface of the Earth is cooler, so the mantle, the rock, will rise and also sink, just like what happens with air. Okay, so this Philippines plate is being pushed underneath the Earth's crust, and so that's the reason volcanoes like Mount Pinatubo erupt, which they actually did not too long ago. One of my students, their dad was living there at the time and took a picture from his hotel, which I think is pretty neat. So these are just some pictures of a volcanic eruption. And the ash that can flow out, which doesn't have to do with convection. Okay, but if you're interested in volcanoes, there's some videos picked out that you can take a look at. Lots of them actually, just because volcanoes are cool. And that is in the topic 6 page from Planet Earth. Okay, and you're welcome to look at those for fun.